Math 3, Unit 9, Section 7. Today we are going to be talking about solving exponential equations without common bases. Everything so far this unit, they have always had common bases. We've been able to condense, expand, do all that stuff. Okay? So now we're going to look at what we can do if they don't have a base we know how to work with. Okay? Now, we need to recall what we've already learned at the beginning of this unit and how that is exponential equations and logarithmic equations are the same. They're just written in different forms. Okay? So we have log base 5 of 125 equals 3. In exponential form, that is 5 to the third equals 125. They are the same. Okay? Just written two different ways. What is the base on these? The base is 5. Good. Okay, what is the exponent on these equations? 3. Okay, now, with this information, okay, there is something called the change of base theorem. Okay, this is important. You need to know this. The reason why there is a change of base theorem is that sometimes I need to find out the answer for the log, but it's in the incorrect base. In your calculators, we have a button for log. When it doesn't state the base, what base is it? 10. But you'll find that there are many problems where it's not a log of 10, it could be a log base 5. Okay? So if you use this change of base, you can change this so that it is in terms of log base 10. Okay? So what happens is whatever base you're dealing with, so in this case it's C, it ends up becoming, the C goes to the denominator, so log of C in the denominator, and the A, log of A, is in the numerator. Because of that, I can then use my calculator to find out what that answer is, okay? Because this is now in base 10. You can also go the other direction. Okay, so whatever the base is, the base goes to the bottom, base value goes to the bottom, okay, and the other value is on top. And we are going to practice this here in just a minute. Okay, but again, if you had two of them in a certain, and they were in the same base dividing, you could change it into a single log, okay? So what ends up happening is the B value would go away, and then the C becomes the base value, and the value there on top goes in that spot. Okay, so we can go back and forth. Now, previously, we solved these equations like this by approximating. Do you guys remember that? And so, for instance, if I wrote this out, 7 to the first power we know is 7. 7 to the second power is 49. And so we know that the answer should be between 1 and 2. Do you guys agree with that? So now they want us to find, well, what's the exact value? Find that, okay? And we can do that by using this information. So we're going to work through it, okay? The other thing I want to remind you guys of is that you need to always read the instructions, okay? So on these examples, they want us to first solve for x. That is our number one thing. Okay? Then it says to write your answers in terms of logarithms in two different ways. Okay? And then it says then evaluate your answer using a scientific calculator and round to the nearest thousandths place. So there's basically 3 different things that we have to do for each of these problems. Okay. So in order to find this answer, the first thing we're going to want to do is go back to log form. So right now it's in exponential form. I cannot get 30 to be base 7, and so I'm going to turn it into log form. So how do I work backwards and go to log form? How would I write it? Log base 7 of 30 equals x. Okay, so first of all, right now, we just solve for x. Do you see how x is by itself? Okay, first step is done. Okay, now the second step says write the logarithms in two different ways. So right here, this is one way. The other way that I can write it is by using my change of base theorem. Okay? And I'm going to put x on the left because I just like to write it that way better. And so it'll be x equals, and we're going to write it as 2 logs, right? So on the top is going to be what? Log of 30. And the denominator will be log 7. And I didn't write what base it is, which means it's actually what base? 10. Okay, so right here we have our two different logarithm equations. This is 1 and this is 2. Okay, we just answered step 2 with our 2 equations. Okay, then evaluate using a scientific calculator. If you do not have a scientific calculator right now, go and grab one from the back, and then we're going to work through this together.
I mean, they're not bad. I got it.
Okay. So, what we are doing here, there is more than one way of plugging in this information. Depending on your calculator, you can do it different ways. Okay, I'm going to show you the way that should work every time in every calculator. So how I do this is, I first type in the top, which should be log of 30. So on my calculators, the log is right under the second key. It could be different if you have your own calculator. But I'm going to type in log and then 30. You want to get good about, if you notice there's parentheses, you should close the parentheses. It won't make a difference on these calculators, but some it will. Okay? And then I just press enter. So that gives me my decimal for the top. I then just leave that in the calculator, and then I'm going to put divided by. So now notice how it says answer, divided by, and then I'm going to type in log of 7 and close my parenthesis. Now it said round to the nearest thousandths place. How many decimal places is the thousandths place? 3, but that means you need to look at the fourth. And if the fourth one is 5 or bigger, we have to round up. So therefore, my answer will be what? 1.748. Okay? And that's my answer using the scientific calculator. Would you guys like me to go through the calculator one more time? Okay. So one more time, for those of you that missed it. Because these are now in log base 10, I can use my calculator. Your calculator, you can only use log base 10 or natural log. Okay, so I type in log, and on the top it's 30, so I type in 30, and I get the answer. So that's my answer of log 30, and then we just press divided by, and so it's taking what my answer was, and then dividing it by log 7. So then I just type in log 7, close my parentheses, and press enter, and I get my decimal that I round to the nearest thousandth. Are there any parts here that you want to ask me about? Okay, let's move on to the second problem. Are we good? Okay, so here is our problem. 74, I cannot make it into base 8. Do you guys agree? Yes. So because of that, we're going to end up having to go back to log form. Now one thing, and I forgot to go talk about it on here, but my answer is supposed to be between 1 and 2. Is this answer between 1 and 2? Yes, so it's a way of just checking, okay? Now on this one it's a little different, but if we're kind of giving ourselves an approximate, 8 to the first power we know is 8, 8 to the second power is 64, and 8 to the third power is 512. Okay. Now, what that means, though, is that you want the exponent to be something equal to between 2 and 3. Okay? But there's already a 2 up there. Do you guys see that? So that means x would actually have to be a value between what? 1 and 2. Okay, so I'm just going to put x should equal something between 1 and 2. Okay. So here we're going to go ahead and change this back into log form. how will I write that?
Log
Log base
base 8, 74.
8 of 74 equals 2x. Okay, is x by itself? No. Okay, what do I need to do? Okay, divide by 2. Now, this makes it a little bit more complicated because this log base 8 of 74 is stuck together. You can't divide 74 in 2. Okay? So another way...
Miss also, it's between 2 and 3. Why is it not?
Okay, can somebody explain to D'Angelo why it's not between 2 and 3? Okay, do you see it? Well, okay, so what's happening here is that we're talking about just the x value. So you're wanting the whole exponent to be between 2 and 3, but because there's another 2 there, it's like you're taking this 2 and dividing it by 2, which would be 1, and this divided by 2 would be 1.5. And so it's really between 1 and 1.5 is what value you would need for x in order for it to be between those values. If this is too confusing, you could just not worry about it too much because we're just approximating right now anyways. Okay, so when we divide by 2, I just said this, but we got distracted for a second. So can I go 74 divided by 2? No. This whole part, it's not like you just have a 74. It's saying log base 8 of 74. That right here, this is one number. Okay? So that is stuck together. So the way I can rewrite it is you could leave it like this, but in terms of when we're going to end up putting it in our calculator, you would want this as x equals 1/2 times log base 8 of 74. So when you're dividing by 2, it's the same as multiplying by 1/2 or 0.5. So if this had been 5x, okay, what would go out in front here? 1/5, okay? So whenever you're dividing by a value, it's the same as multiplying by 1 over that value. Does that make sense? Okay, so this right here is one way of writing x equals for the log equation. Okay, now we need to do the second way, where we use our change of base. Okay, when you're doing the change of base, what will go in the denominator? Log 8. And what would go in the numerator? Log 74. You could put 1/2 with the top, or it could be, you could have a 1 on top and a 2 on the bottom, or you could just have a 2 there. Okay, either way. Are we okay with this? Okay, so this is a second way of writing this. Now we're going to plug it into our calculator. Are you ready for the calculator? Okay. Again, there's more than one way of doing this. I want to just do the log parts first. Or I'm going to show you 2 different ways of doing it. So if we type it the way it's written here, we would find log of 74, correct? Yes? Equals that, okay, divided by, and if you want to keep the 2 like this, you would want to put a parenthesis and go 2 log 8. And you have to close both of the parentheses. And you cannot see what I was writing because of the reflection, sorry.
You just multiply it by 2 after.
You can divide it by 2 after. Yes. So when you press equals there, you get, rounding to the nearest thousandths, what is that? So it'll end up being 1.035, correct? When we round to the nearest thousandths? Okay, now Jacob said, could we just do the logs and then divide by 2 at the end? And the answer is yes. And I think that might even be easier. So if you did log of 74 equals divided by log of 8, And you get that, and then the last thing we do is just divide by 2. Oops, that's a 5. That's a 2. And you get the same answer. Because remember how before we had both of the logs and then divided by 2? It's up to you. Michael, you're getting this? Okay. So, here's this next one. What do you think we should do first? Not exact. So we need to get like this. This right here is all stuck together. Do you guys agree? This isn't really saying 5 times 2. It's saying 5 times 2 to the 5x. And so we need to first get rid of that 5. What would I do to get rid of that 5? Very good. Divide by 5 to both sides. Okay. So now I have 2 to the 5x equals, and 400 divided by 5 is what? Or 80, correct? Okay. Yeah, so do you guys like kind of having an approximate of your answer? Or is that part confusing to you? Do you like knowing like approximately what your answer should be? So it doesn't really matter, but if you were way off, it would hopefully give you an idea that you're way off. So for those of you that kind of care about it, we know that 2 to the 6th power is 64, and 2 to the 7th power is 128. D'Angelo, this is for you because it didn't quite make sense before. We want the 5x to equal 6 or the 5x to equal 7. So what I mean by that is 5x equals 6, you would divide by 5. So x equals 6 over 5 or 1 1/5 or 1.2, okay? Or 5x to 7 and you divide by 5, and so x would equal 1 2/5, or that's the same as 1.4. So my answer should be between 1.2 and 1.4. Does that make sense? Okay. Just to give a better explanation as to why it's not going to be 6 and 7, because we already have that 5 up there. Okay, so now we have an approximation. What will I do to find the exact answer? How do I rewrite this first? Log base 2 of 80 equals 5x. Is x by itself? No, divided by 5. Okay, so when I'm dividing by 5 here, it's the same as what? Multiplying by 1/5. Do you guys see that? Dividing by 5 and multiplying by 1/5 is the same. Therefore, x equals 1/5 log base 2 of 80. And that is one way I can write that in log form. Okay, the second way we write it in log form will be what? Change of base theorem.
Log 80, log 2.
Okay, where does log 80 go? And then log 2 goes in the denominator. And then you can have the 5 in the bottom, or you could put times 1/5, either way. That is our second way of writing that. Do we have questions? Now we need to find the answer in decimal form. I'm going to give you guys a minute to try to find it on your own before I do it with you. Okay? Okay. You should have got, did you guys get an answer yet?
Yeah, 264.
1.264 is correct. Okay, 1.264. Okay, so I think the easiest way is to do both of your logs, get the answer, and then divide by 5. Okay, so log of 80 equals 1.903 divided by log of 2, which equals 6.3219, divided by our 5. 1.264, and we don't round up because the other number's a 3. Is this value in between the two that we found should be our estimate? Yes. Is there a part on this problem that you want me to go back to? Okay, next problem. Okay. Can I change 32 to be base 7? Okay. So what am I going to do? Since I cannot change 32 to be base 7, we have to use logs. So we write this as log base 7 of 32 equals x plus 2. Is x by itself?
No.
What will I need to do? Subtract 2. If you want to take 32 minus 2, you might want to always highlight the log parts or something because all of that's stuck together. That 32 is connected to the log base 7. I cannot subtract 2 from it. Therefore, my answer right now is that x equals log base 7 of 32 minus 2. That's it. I can't do anything else there. Okay? Now, what would be the other way of writing this log equation? You would use your change of base. Okay? Which means we would write that as x equals log of 32 over log of 7 and then minus 2. The second equation is the one that we can use in order to find the decimal answer. Okay, so try this in your calculators. Yes, your answer will be negative. Okay, so the correct answer should be negative 0.219. And if you put that in there, negative 0.219, am I going to get a negative value there? No, because it's adding 2 to it. You're going to get 1 point something. And can you have a negative as an exponent? Yeah, it just makes a fraction. But this one, it doesn't even make a negative exponent. Okay? So, for those of you that did not get that value, let's work through this here. Okay? So, what you would start by doing is taking log 32 equals, you get that 1.0 or 1.5051 divided by log of 7 equals 1.7810. Okay, and then what do I do now after that? You just have to subtract the 2. And that is how you get this value. And when you round it to the nearest thousand, because of the value next to the thousands place is 5 or higher, we round that up. And so that's how I get negative 0.219. Do we have any questions? Okay, let's turn to the next page. Okay, again, it's always important to read the instructions. Okay, here they are asking us to solve for x. Then they ask us to write the answer in terms of logarithms. Did it say I have to do 2 different logarithm forms? No. Okay? Then it says, then evaluate your answer using a scientific calculator and round to the nearest thousandths place. Okay. Now, on this problem, you always are trying to get that by itself. Okay, your exponent. Very good. Subtract 2. Can I subtract 2 from 15?
Yes.
Yeah. Okay, 10 to the 4x equals 15 minus 2 is 13. Can I change 13 to be base 10? No. If I could, that would be way easier. But I can't. So I have to turn it into what form in order to solve it? To log form. It's in exponential. We want to turn it to log form. Okay? So when I write this in log form, it's going to be log what?
Log base 10, 13 equals 4.
Do I need, if it's log base 10, do I need to write that? So I'm not going to. Okay? So it's going to be log base 10, but I'm not writing the 10, of 13 equals 4x. Okay, is x by itself?
No.
No. What do I need to do?
Divided by 4.
Divide it by 4. And so x equals log 13 divided by 4. Now remember that log of 13 is all stuck together. So do I need to change base or anything with log of 13? No. Can I use my calculator? Yes. Exactly. Because this is already base 10, I don't have to use my change of base theorem. So in here we go log of 13, get our answer, and then what do? Divide by 4. Therefore the answer is 0.278 when I round to the nearest thousand.
Wait. So you don't have to do the original?
Because it was already in base 10, we don't have to use the change of base theorem. If you did, you would still get the same answer. Okay? Do we have any questions? All right, next problem. We are trying to get this by itself. What do I do with the 3 in front?
Divide it.
Very good. Divide by 3. We have e to the x minus 4 equals, and 21 divided by 3 is 7. Now, can I change 7 to be base e?
No.
No. Therefore, I need to introduce logs and change into logs. And because this is base e, I'm going to use what type? Natural log. And so for natural log, do I need to write base e? No. Just like here, I didn't end up writing base 10. I don't have to write base e. But if you want to, you can. Okay? So it'll be natural log base e of what? Of 7 equals x minus 4. And then what will I do to get x by itself?
Add 4.
Okay, the natural log of 7 plus 4. Can I add 7 plus 4 together? No, because the log part is always stuck together. Those are something totally different than 7. Okay? Can I find this answer in decimal form now? What will I do? Yeah, do you guys see where natural log is on your calculator? Yeah, it's right below your log button or right next to it, depending on your calculator. So there's natural log of 7 equals 1.946 to the nearest thousandth plus 4. So therefore my answer is
5.946.
very good. Any questions? Okay. Last part. This last part, it's like your bonus question, okay? It will not actually be on your test, but this is something that you need to know for calculus, and you might see an extra credit problem on your test that looks like this, okay? Are you ready? Okay, instructions say, solve equation for y in terms of x. So all we're going to do is solve for y. Highlight the part that has y in it. So right here, this is the part that has y in it. We want to get y by itself. We are solving for y. What would I do first in order to get y by itself? Subtract 7. Okay, so now I have 10 to the 3y minus 1 equals x cubed minus 7. Now, looking at this problem right now, there is no way I could solve for y the way it is written. So we are going to introduce logs. We're going to write this as a log equation. How would I write that? Log base 10. So do I need to write the base 10? Nope. Of what? Of x cubed minus 7. And you're going to want to put that in parentheses so you know that whole part is connected to the log. Okay? Equals what? Equals 3y minus 1. Now we want to get y by itself. What would I do next? Add 1. Can I add the 1 and the negative 7 together? No. Good. So keep that all in parentheses so you know it's connected to the log. Equals 3y. And then your last step would be to divide by 3. And that's all you would do for this problem. Y equals log of x cubed minus 7 plus 1, all divided by 3. Okay, one more. Again, we are trying to get y by itself. Okay, I'm highlighting this portion right here because that's where the y is. What would I do first? Good, subtract 6. Natural log of 2y plus 5 equals x to the 4th minus 6. The way it's written, I cannot solve it, so I need to change it into exponential form this time. Natural log is base e, so I would rewrite this as e x to the 4th minus 6, and if you want to, you could put that in parentheses to make sure you remember all that's to that exponent, equals 2y plus 5. And again, we're trying to just get y by itself, and so the next thing I would do is subtract 5, e to the x to the 4th minus 6, and then minus 5 equals 2y, and your last step would be to divide all of that by 2. So y equals e x to the 4th minus 6 minus 5 divided by 2.